Okay, guys, welcome back to Backend Magang. Stay humble and keep the excitement to learn like newbie intern. Good morning, everyone. So far, we've been diving deep into technical topics in my contents. But I know it can get a bit heavy at times. And yeah, that's why today we are shaking things up a bit. And we're going to explore the incredible journey of coding, a story that started with simple command and has evolved into the powerful language we use today. Yeah, like Python, Ruby, Swift, Kotlin, or even Golang. But as we look back at this fascinating history, we cannot help but wonder with AI on the rise, what does the future hold for programmers? Will we see a transformation or will AI take the reins? So stick around as we explore the past, present, and future of programming and discover how this change might impact all of us. So keep on watching and let's get it on.
Please like, share, comment, and subscribe.
Okay, the first one is the early era, the birth of digital computing. So when we talk about the birth of digital computing, we have to talk about Alan Turing and the Turing machine. Okay, Alan Turing is often called the father of modern computing. Back in 1936, Turing introduced the concept of the Turing machine, a theoretical device that could execute a sequence of instruction to carry out mathematical operation. This foundational idea paved the way for the modern computer we use today, establishing a model in which a device can process instruction and perform calculation in a structured order. And during the Second World War, Turing joined a team of cryptographers at Bletchley Park in England. Uh, yeah, his main focus was breaking the code of the Enigma machine, a cheaper device used by Nazi Germany for secure communication, of course. And with his team's brilliance and dedication, Turing developed a machine called the Bombay, which could rapidly decipher enigmas and coded messages. This breakthrough was instrumental in helping the Allies win the war, of course, likely shortening it by years. And although Turing's contribution to computing and cryptography were monumental, he faced many personal and social challenges. He endured significant discrimination due to his sexual orientation, a factor that greatly impacted his later life. So, despite this hardship, Turing's legacy lives on, and his pioneering work continues to influence every piece of computing technology we use today. And after Turing, we moved to Grace Hopper. And the compiler revolution. Uh, Hopper was a U.S. Navy officer and computer scientist whose work transformed programming. In 1952, she created the first compiler, a software tool that translates programming instruction from human language into code the computer can understand. And this innovation paved the way for the development of high-level programming languages, allowing for broader access to programming beyond low-level machine code. And Hopper also play a key role in developing COBOL, Common Business Oriented Language. A programming language designed specifically for business and government application. And remarkably, COBOL is still used today in system for banking and government. And underscoring Hopper's impact on durable programming design. Beyond her technical contribution, I'm sorry, beyond her technical contribution, I mean, Hopper was a trailblazer for women in technology, a field that was then predominantly male. She actively promoted diversity in computing and advocated for making coding accessible to a broader audience, stressing its importance in shaping the future. Yeah, after the early era, here come the first languages: Fortran, COBOL, and Lisp. Yeah, as computer technology advanced in the 1950s, there emerged a need for a way to communicate with machine using language that could be understood by scientists and engineers. And during this era, the first programming language were created, and it's designed to meet different needs. So yeah, here's the brief overview of three revolutionary early programming languages: Fortran, COBOL, and Lisp. So the first one is Fortran, the language for scientists and engineers. Okay, Fortran, short for Formula Translation, was developed by John Bakers and his team at IBM in 1957. It was specifically designed for scientific and engineering computation, enabling scientists to write code that could quickly solve complex mathematical calculation. A simple analogy would be to compare Fortran to writing a receipt. It helps to organize a sequence of instruction to achieve a specific result, much like formulas in science. So yeah, as you see on my screen, I have an example for tan code for calculating the area of a circle. Sorry. Yeah. At that time, Fortran was revolutionary because it accelerated scientific research and engineering effort instead of writing instruction in complex machine code. Scientists could leverage a more human-friendly language to carry out their computation. Yeah, after Fortran, the second one is COBOL, the business language that connects the world. Yeah, COBOL or Common Business Oriented Language was developed in 1959 with Grace Hopper as one of its pioneers. This language focused on business application and the management of large data sets. COBOL was designed to be easily readable even for non-programmers, similar to how an accountant can read financial reports. And yeah, its clarity made COBOL popular in the business sector as it is well suited for data management and transaction recording. Even today, COBOL is widely used in many banking and government systems. And on my screen, I've shared the example COBOL code for calculating employee salaries. And COBOL's popularity stems from its ability to handle data processing tasks efficiently, making it integral to the operation of numerous business and government agencies around the globe. Yeah, its design emphasizes readability and maintainability, which has helped it to endure over the decades. And last but not least, for the first language, Lisp, the language for artificial intelligence and data processing. Lisp, it was developed by John McCarthy in the late 1950s. Lisp or Lisp processing was designed for data processing, AI development, and symbolic computation. Yeah, unlike other programming languages, focus on functional programming, allowing function to be treated as first-class object and processed within a highly flexible tree structure. Yeah, this flexibility is particularly valuable in AI development. And as you can see on my screen, I have example Lisp code for finding factor of a number. And Lisp revolutionized programming by introducing a new way to think about code. It enabled programmers to create more dynamic and modular code, which is essential for developing intelligent systems that require flexibility. So yeah, why these languages were revolutionary? Yeah, at their time, Fortran, COBOL, and yeah, and also Lips changed how people interacted with computer. Previously, if you merely as calculating machine, this language open up new possibilities. Yeah, Fortran connected computer with the scientific community, accelerating research that require intensive computation, and COBOL brought computer into the business realm, aiding in the management of massive data set and transaction recording, and Leaf's venture into artificial intelligence, enabling more complex data processing and laying the groundwork for functional programming languages. Yeah, this early programming language not only assisted technician and scientists, but also broadened the scope of programming, allowing computer to be integrated into various fields of human life. Yeah, their influence. I'm sorry. Sorry guys. Yeah, their influence is still felt today in modern programming. Yeah, I mean in modern programming language that continue to develop the concept they introduce. After the first language, here comes revolution of the 70s and 80s, the rise of C and basic language. So in the 1970s, I'm sorry 1919 I mean I'm sorry. Yeah, in the 1970s, the computer industry witnesses the birth of programming language that laid the groundwork for countless. I'm sorry, I'm sorry, guys. My my English is still bad. Yeah, I will repeat. Yeah, so in the 1950s, the computer industry, there witnesses the birth of programming languages that laid the groundwork for countless technologies and innovation. Yeah, among the languages that emerged during this era, C and Basic play pivotal roles in driving the programming revolution. It's having a unique impact on the tech world. Yeah, the first one, the C language, the building tool that creates other building tool. C was developed in 1972 by Dennis Ritchie at Bell Labs. Yeah, the C language was designed to efficiently develop operating system, particularly Unix. And one of C's key advantage is its ability to interact directly with hardware, allowing developer to write program with a high level of control over memory and computer resource, and all while using syntax that easier to grasp compared to assembly language. And that's why C is often referred to as the building tool that creates other building tools. Yeah, as it enables the development of more complex software. Yeah, C served as the backbone of modern system, forming the foundation of Unix, which later inspired other operating system like Linux and parts of Windows. Its flexibility has also made it a cornerstone for many popular programming languages like C++, Java, and JavaScript. Yeah, which borrow syntax and concept from C. And then the second one is basic language programming for everyone. Yeah, during the same decade, basic or beginners all-purpose symbol-based instruction code was introduced as an easy-to-learn programming language aimed at educational and hobbies use. Developed by John Kennedy and Thomas A. Kurtz in 1954, Basics gained popularity with the rise of home computer like the Apple II, Commodore 64, and IBM PC throughout the 70s and 80s. Yeah, Basic opened the door for a new generations, student and hobbies alike, to quickly learn programming without needing specialized training. Home computers such as the Apple II and the RS-80 came preloaded with BASIC, making it accessible for anyone with a computer to write their own code. Yeah, this accessibility paved the way for the personal computer revolution, bringing programming closer to the general public and making BASIC a go-to introduction for millions. Yeah, and also Basic enable user to create a simple program like games, calculator, and small application that have the fundamental of programming, which is yes, straightforward, command-based syntax. Basic become a top choice for teaching programming. Yeah, preparing young generation for more complex technological development. Yeah, after the 70s and 80s, we move forward to startup and mobile era, changing the way we build and use application. Yeah, as we enter the 2000, a new era are emerged that revolutions application development. That the spirit of launching innovative startup across various fields push developer to seek more efficient ways to create and launch their products. Yeah, at the same time, the rising use of smartphone led to the creation of mobile app ecosystem, making daily life more connected and automated. So, two key technologies that play significant role in this trend were Ruby on Rails and programming language for mobile like Swift and Kotlin. So the first one is Ruby on Rails, the startup catalyst of the early 2000. Yeah, Ruby on Rails, or simply Rails, was first released in 2004 by David Heinemeier Hansen. Built on the Ruby programming language, Rails made it easier for developer to quickly and efficiently build web application thanks to its principle of convention over configuration or COC and don't repeat yourself DRY. Yeah. So with Rails, many technical steps in web application development became simpler and more structured. Yeah, allowing developer to focus on application logic instead of dealing with complex configuration. And Rails quickly gained popularity among startups due to its rapid and flexible approach. Yeah, many big companies grew relying on Rails to develop their application, including Twitter, Shopify, or even GitHub. GitHub use Rails. So Rails help developer produce minimum viable products or MVPs in a short amount of time. Yeah, which is crucial for startup to test their ideas in the market before developing more complex feature. Yeah, the simple yet effective approach speed up product launch times. I mean, and encourage many startup to innovate quickly, earning Rails the nickname the startup framework. Yeah, for the mobile era, there are Swift and Kotlin, programming language for the mobile era. Yeah, with the rises of smartphone, the tech world shifted its focus towards mobile app development, of course. Yeah, to meet this demand, specific programming language for mobile device were developed, with two main ones, being Swift for iOS and Kotlin for Android. So the first one, Swift, developed by Apple and introduced in 2014, Swift replaced Objective C as the primary language for iOS app development. Designed to be modern, safe, and fast, Swift has a syntax that easy to learn, making it accessible even for beginner developer. Yeah, with full support from Apple. Swift offer high performance and stability for mobile apps in the iOS ecosystem, enabling developer to create elegant, intuitive, and fast iPhone application that enhance user experience. And after that, Kotlin, Meanwhile, for the Android ecosystem, Kotlin was introduced as the official language by Google in 2017, replacing the previously dominant Java. and Kotlin was designed to be compatible with Java, but offers advantage in simplicity and code safety, such as its null safety feature that help reduce bugs. Yeah, with Kotlin, Android app development become more efficient and enjoyable, allowing developer to build safe and high quality application. Oh yes, I have to. I still have explanation for this slide. Yeah. So the impact of the startup and mobile era, yeah, Ruby on Rail, Swift, and Kotlin, yeah, it's made significant impacts in the world of application development, especially during the startup and mobile era. Yeah, an example, Rails enables startup to launch products quickly and supported rapid iteration, allowing for swift innovation. And Swift and Kotlin facilitated faster, safer, and easier mobile app development. Yeah, it accelerating innovation in mobile app. Yeah, of course, the mobile app ecosystem that is now crucial to everyday life. So as software becomes increasingly interconnected in our daily routines, from transportation and banking to communication, yeah, the application built using Rails, Swift, and Kotlin have popular technological advancement and enriched user experience, on a global scale. Yeah, this is the important part. I think AI and the future, will coding be taken over or transformed? Yeah, as we step into the current era, yeah, Python has emerged as the go-to language for AI and machine learning. It's easy to learn, has an extensive open source library ecosystem. Yeah, of course, library ecosystem for AI like TensorFlow, PyTorch, yeah, and it's backed by a vibrant open source community. Yeah, its flexibility and versatility make Python a top choice for researchers and AI practitioners. Yeah, allowing them to quickly build, test, and of course, implement the AI models. So, why Python? Yeah, Python stand out in AI for several key reasons. Yeah, the first one is simple syntax. Yeah, Python allow researchers to focus on algorithm and data without getting bogged down by the technical complexities. And the second one is a rich library ecosystem. Yeah, libraries such as NumPy, Pandas, Scikit-learn, TensorFlow, and PyTorch expedite AI and machine learning development. And Python also has an active community. So Python benefit from a large community that continuously update and enhances its libraries, keeping AI development in Python current and relevant, of course. So Python is made. Yep, I think Python is more than just a programming language. It serves as a bridge for scientists, engineer, and developer to turn advanced AI ideas into reality. Yeah, after that, will AI replace programmer? Yeah, this is what I'm thinking. Yeah, a big question that often comes up is, will AI replace the profession of programming? Yeah, while AI and automation have taken over certain jobs, the programming profession might be in different position. Yeah. Okay. I think here are some reasons why AI might not fully replace programmers. So the first one is creativity and problem solving. Yeah, programming is more than just writing code. It requires critical thinking, problem solving, creativity, which are tough for AI to replicate completely. Yeah, while AI can assist with code suggestion, I'm sorry, suggestion. Oh, my English. Yeah, well, AI can assist with code suggestion or even generate code. But human programmer will still play a crucial role in decision making and crafting creative solution. And the second one is AI as supporting tool. Yeah, on the flip side, AI is more likely to serve as an assistant to programmer rather than a replacement. Yeah, for instance, with the help of AI coding assistant like GitHub Copilot, even ChatGPT, yeah, programmer can complete tasks faster and focus on higher level application logic and architecture. So yeah, AI can automate routine tasks and enhance the speed of software development. That's the point, I think. And yeah, how will programming language evolve for AI? As AI continues to evolve, programming language might also change. Not just to boost efficiency in AI development, but to provide a more integrated experience for developer. Yeah, some potential change include, the first one is more human-like syntax. Yeah, programming language may be designed to resemble human language more closely, yeah, making interaction between human and machine more intuitive. And after that, the integration with artificial intelligence. Yeah, we might see more languages that directly integrated with AI, allowing them to offer suggestion or optimize code simultaneously. And high abstraction and automation. So yeah, future language could provide high level abstraction for complex processes, especially in AI domains, allowing developer to focus on outcomes and goals without getting mad in the technical details. So yeah, the last but not least, the human role in automated era. Yeah, in an increasingly automated text landscape, the human role in software and AI development is likely to shift from repetitive technical tasks to focusing on planning, strategy, and data driven decision making. And yeah, this means that while some aspect of coding will become more automated, and human will still be needed in design, analysis, and oversight. Yeah, an interesting aspect is how the human AI partnership will shape the future of technology. So yeah, humans may take on more of a guiding or directing role for AI, preparing data and providing the necessary input for the system to function effectively. So this reflect a shift toward an era where we develop new ways to collaborate with a machine rather than simply replacing our tasks with automation. So yeah, and there you have it. We've journeyed through the fascinating history of coding, exploring its evolution and the exciting possibilities that AI brings to the table. So yeah, remember the future of programming is not about replacing human creativity; it's about enhancing it. Yeah. So if you enjoyed this content and found it valuable, please give it a thumbs up, subscribe to my channel, and leave your thoughts in comments below. Yeah, your support have keeps this channel going and allows me to bring you more engaging content. So don't forget to share this video with your friends and fellow tech enthusiasts. Until next time, stay curious, keep coding. Thank you very much, and cheers, Backend Magang.